Welcome back. We're going to do some examples of geometric mean in this video. So remember, your geometric mean is the number that is going to go in your numerator of one fraction and your denominator of the other in a proportion, and it's the geometric mean between the other two given numbers. Sometimes you're trying to find what one of those given numbers are. Your geometric mean is always the same in both places. Okay? We have two theorems that use the geometric mean that go with right triangles. The first one is the Altitude Theorem that says the altitude in a right triangle is the geometric mean between the two parts of the hypotenuse. And the second one says that the right triangle leg theorem says the leg of a right triangle is the geometric mean between the hypotenuse and the part of the hypotenuse that's adjacent to the leg you're working with. Okay? So let's look at some examples as we go on in the notes. Okay? My first one says find the geometric mean between each pair of numbers. Okay? All right, so this one, I know the geometric mean between 6 and 9 is going to be in the denominator of one fraction and in the numerator of the other. So I'm going to have what is the geometric mean between 6 and 9. Okay, so now I just need to cross multiply. When I cross multiply, g times g, my geometric mean times the geometric mean is g squared, equals, then I'm going to do the 6 times the 9. 6 times 9 is 54. Now, to get rid of a square, I need to square root. To unsquare, we square root, because squares and square roots cancel, so on the left-hand side, I just have a g. And on the right-hand side, the square root of 54, so remember we're going to turn our calculator sideways. We're going to type the number in first, 54, and then we have the square roots. One has a 2, one has a 3, and one has a y on my calculator. I want to square root, so I want the one with the 2. And then we're going to round to 3 places. So we look at 3 places after the decimal, 0.348. Look after that 8 to see if you need to round up. It's only a 4, so I don't. So I just put 7.348. So 7.348 is my geometric mean between 6 and 9. Okay, let's look at another one. Okay, let's look at the geometric mean between 1/2 and 2. So I know I'm going to be looking, my geometric mean is going to be in the denominator of one fraction and the numerator of the other. Geometric mean. And my two numbers are 1/2 and 2. Now sometimes it's weird to try to put a fraction in a fraction. So if you want, we can change this 1/2 to 0.5 and then 2. That's going to make it a little bit easier to cross multiply. I'm going to get g times g, which is g squared. That's going to equal 0.5 times 2, which, let's see, 1/2 of 2 is 1, right? But just to make sure, 0.5 times 2 is 1. Okay, and then to get rid of the square, we're going to square root on both sides, because squares and square roots cancel. So g equals the square root of 1, and it's already in my calculator. I just have to hit that square root button, but it looked like nothing happened, right? Well, let's clear that out. 1, square root, nothing happened. Well, because the square root of 1 is 1, right? Because it takes 1 times 1 to make 1. So my geometric mean there is 1. The geometric mean of 1/2 and 2 is 1. Okay? All right, so now notice I have 3 right triangles, because in the corner of the main right triangle, or the main triangle, is my right angle. In all of them, I do have the altitude drawn. It hits the opposite side at a 90-degree angle. It hits the hypotenuse at a 90-degree angle. Okay? So these are going to be using our two theorems. The hardest part on these is probably figuring out, are you using the altitude theorem or are you using the leg theorem? Okay? So when I look at this first one, I do have an altitude drawn in, but they all have to have altitudes drawn in. So I need to look and see, what am I looking for? Am I looking for a leg or am I looking for an altitude? Okay? In this one, I'm looking for the leg. So that means I want to use the leg theorem. Okay, my leg theorem said that in my geometric mean, or in my proportion, the leg was the geometric mean. So here and here. The leg was the geometric mean between the hypotenuse and the adjacent part of the hypotenuse. Okay, so in this figure, my leg is x. So in my proportion here, my leg is my geometric mean. So here and here will be the same, and the leg here is x between the hypotenuse and the adjacent. They gave me the hypotenuse. The hypotenuse is 6, and then the adjacent part, so if I leave the end of the leg and start highlighting the hypotenuse, my adjacent part is 2. Okay, so now I just need to cross multiply and solve. So when I cross multiply here, x times x is x squared equals, and then here, 6 times 2 is 12. To get rid of a square, we square root. So x equals the square root of 12. Let's see what that is. The square root of 12, clear that out, 12, and then square root, 3 point, and we're going to go to 3 places, so 3.464, and then look after that 4 and see what it is. It's a 1, so I leave it exactly as it is. 3.464. 3.464. Okay. Let's look at the next example. On the next example, they also have the altitude drawn in, and this time I am trying to find that altitude. So this time I am going to want to use the altitude theorem because I'm looking to try to find the altitude. The altitude is the geometric mean between the 2 parts that the hypotenuse is divided into. Okay, so I'm going to write it down here. My altitude is the geometric mean, so that's the one in the 2 places that match between the 2 parts, part 1 and part 2 of the hypotenuse. So again, my altitude is the one that is the geometric mean. Okay, so now all I have to do is fill this in. My altitude is the geometric mean. My altitude in this figure from the right angle to the opposite side at a right angle is y. Y equals, or y is the geometric mean between the 2 parts. Now look at my 2 parts. I've got 2, and I've got, I don't know, but one of them is definitely 2. How long is this part? Well, if the whole hypotenuse is 6, and I've gone 2, I just subtract. 6 minus 2 equals 4. So this piece here must be 4, so that all the way across is 6. So my 2 parts of the hypotenuse are 2 and 4. And this I can cross multiply to solve. Y times y is y squared equals 2 times 4 is 8. And then to get rid of the square, we're going to square root. And y equals, let's see, the square root of 8. So clear that out. 8 square root, round to 3 decimal places. So 2.828, look after that 8, and we get a 4. So I don't have to round it up. It's just 2.828. Okay, 2.828 is my answer. Okay, and the last one over here on this row, I have the same picture, but this time I'm trying to find z over here, and z is a leg. So I know I'm going to be using my leg formula that I used on the first one. Okay, so I'm going to just refer back to this formula. Okay, my leg is going to be the geometric mean between the hypotenuse and the adjacent part of the leg. So I'm going to go here and I'm going to go here. And my leg, Z, is the geometric mean between the whole hypotenuse, which it tells me here is 6, just like it was last time, right? The hypotenuse was 6, because it's the same picture. See my two? They're the same picture. But this time I want the part, the adjacent part to Z, which is this piece. And they didn't give it to me, but I figured out in the last problem what it was. That piece there is 4, so that all the way across is 6. 2 plus 4 makes 6. And now I can cross multiply to find Z. Z times Z is Z squared. And 6 times 4 is 24. And all that's left to do is square root, because square roots and squares cancel, and I just have Z equals, let's see, the square root of 24. So 24, clear out what I had there, 24 square root, round to 3 places. So when I look at this, 4.898, and then I look after that 8 and it's a 9, so that means I need to round the 8 up, so I'm going to say 4.899. It's real tempting to kind of try to double round here, but don't. It's 4.89. You just round that 8 up one more, so it's 4.899. 4.899. Only round one time. Don't keep rounding. Just one time. Okay? All right, so there is an example of finding geometric mean given just your plain 2 numbers, and then using your right triangle leg theorem and your right triangle altitude theorem. There are, in the next video, going to be a couple more examples, and I believe even on one of them we'll get to do some factoring, bring in some of those algebraic reasoning and algebra 2 skills that we might be a little rusty on. So if you're not sure on factoring, you're definitely going to want to watch this next video. If you feel comfortable with factoring, if you remember it, and you feel comfortable using applying your 2 formulas, then you are probably ready for the assessment. Okay? Thank you so much for watching.